All right, we are on the last of the final two sections for this course. In the last section, we introduced logarithms, we reviewed logarithms, and we talked a little bit about logarithmic equations and graphing logarithms. All right, the next thing that we're going to do is we're going to talk about properties of logarithms. And for this section, the properties that we're going to be using, it's going to be, well, why are we doing that? And in this section, it's going to be, well, because we can. In the next section, when we talk about solving more complicated equations, then we're going to see how these are actually really applied. Okay. But in this section, we're going to talk about properties of logarithms, and this is just going to be kind of manipulating expressions. All right, so let's go ahead and review some things that we've talked about a lot in previous classes. In previous classes, we had three basic properties of exponents. And so the three basic properties that we had was we had the product rule. And remember that the product rule says if you have the same base and you're multiplying, then what we do is we add the exponents. We also had a quotient rule, and our quotient rule said that if we're dividing expressions that have the same base, then we can subtract the exponents. And the last one we had was the power rule. And the power rule basically said if you have a base raised to an exponent, and then you raise it to another exponent, we multiply the exponents. Now with our rules of exponents, we pretty much only went one direction. With logarithms, we're actually going to go both. And so we do have similar rules for logarithms. And the main thing to keep in mind is we still have the same basic operations, but we're going to be backwards in terms of what we do. So for instance, in the product rule, when we multiplied, if we had multiplication, when we combined, we added. And it's going to be opposite for logarithms. If we have a logarithm and we are multiplying the insides, when we separate it, we turn it into addition. So here, when we combine, we add. Here, when we separate, we add. Quotient rule. When we talked about our quotient rule, when we combine, we subtract. And when we talk about logarithms, when we have a division on the inside, when we separate it, we subtract. But notice that we do still have the same basic things. Multiplication and addition are paired together. Division and subtraction are paired together. And the last one that we have is our power rule. And the main thing to keep in mind is when we talk about logarithms, logs are basically just the exponents. We saw that when we looked at our around the world trick. We saw it when we canceled logs and bases of exponentials. And so basically, the last one that we have is our power rule. And the important thing to keep in mind here is when we look at this power rule, this is basically log base m is an exponent. We are raising it to another exponent. And that turns into multiplication. And so what we do is we take our exponent here, and we're going to move it to the front and change it into a multiplication. Now, as I mentioned, exponents, rules of exponents, we pretty much only went one way. We combined. When we talk about properties of logarithms, we are going to want to be comfortable with combining and separating. Okay? And just remember, when we combine, we turn it into multiply, divide. When we separate, we turn it into add or subtract. The last one that we're going to talk about in this section is change of base formula. And change of base formula is if we have log base b of a, and we're assuming that b is not one of our standard logarithms. It's not log base 10, it's not log base e. And so how do we evaluate things like that? Well, we still have to use our calculator. But what we can do is we can go ahead and separate this. We're going to do log of a divided by log of b, or natural log of a divided by natural log of b. And the way that I think about this is when I look at this, to me, the b is already going to the bottom. The a is already going to the top. And then we just have to put a log in front of both of them. All right, let's go ahead and start with some examples. And again, for this section, we're just going to play around with combining and separating and getting a little bit more comfortable with these properties of logarithms. All right, the first ones that we're going to look at is we want to use properties of logarithms to expand each expression. We want to write it in terms of adding and subtracting, and we don't want any exponents running around, which means that we want to move all of our exponents down to the front. All right, so let's see what we have here. For example A, we have log of x, y. And so what this is log of x times y. And so multiplication, when we separate this, multiplication turns into addition. And so what this is going to become is log of x plus log of y. And we're done. That's all we're playing around with right now. All right, let's come to example B. B, we have a division. And so remember, division, when we separate it, turns into subtraction. And so what we're going to do is we're going to go natural log of 5 minus natural log of z. And we're done. All right, example C is going to be the one that is the most complicated of these, but let's go ahead and look at it. It's not that bad. All right, this one is going to be a 2 or 3 step problem. The first thing that I see is I do see a division. And so division, when we separate it, turns into subtraction. And so we're going to go log base 4 cube root of x minus log base 4 square root of k. Now, if you recall in the instructions, it said that it did not want it written with exponents. And remember that roots are technically exponents. So the next thing that I'm going to do is I am going to go ahead and start by converting my roots into exponents. And so remember that when we do this, our exponent, the numerator is the exponent on the inside. Because there is nothing there, it's going to be a 1. And the root becomes the denominator. So the cube root of x turns into x raised to the 1/3. We're going to do the same thing with square root of k. And so this becomes log base 4 of k. The inside exponent, there is none, so it's a 1. Our type of root becomes the denominator. This is a square root or second root, and so it becomes a 1/2. All right, so we've written our roots as exponents. And now what we want to do is we want to move our exponents down to the front. They are going to become coefficients. And so what this turns into is 1/3 log base 4 of x minus 1/2 log base 4 of k. And we're done. This is expanded. All of our exponents are no longer exponents, they're coefficients. And that's basically what we're looking at. We can't do anything else with this. All right, let's look at some more complicated examples. Okay, and we're going to see that these are not going to be all that much more complicated. All right, we're going to start with example D. And the main reason that these are going to be a little bit more complicated is we are going to do some simplifying as well. All right, so we start off with log base 2 of 2x to the 4th. And the first thing that we want to do is we're going to start with our multiplication, and we're going to expand it out. So multiplication, when we separate multiplication, it turns into addition. So this is going to be log base 2 of 2 plus log base 2 of x to the 4th. All right, from here, we can do two things, okay? The first one is I do want to simplify this log base 2 of 2. And remember that if our base in our exponents and the base in our logarithm are the same, they cancel out. I'm going to rewrite this as 2 to the 1 so that we have an exponent there. And what we get is these cancel, and we are just left with 1. In my second term, we have an exponent, and so I can move this down to the front, and this becomes 4 log base 2 of x. We cannot do anything further with this. We have 1 plus 4 log base 2 of x. The numbers do not combine because the only way we combine them is if we have both of them are log base 2 of x's. All right, that takes care of this one. Let's look at a couple more. Okay, the next one we have is ln, natural log, of 7x cubed over k squared, square root of m. Okay, I'm going to do this twice just to show you kind of some of the things that we have. The first thing that I'm going to do is I'm going to take care of my division bar. Now I'm going to subtract. So this becomes ln of 7x cubed minus ln, and I'm going to put this one in parentheses, k squared square root of m. And I said m, not x. Okay, let me try that again. Okay, so now, all right, so now what we have here is we do need to expand this further. Okay, when I look at this one, I see multiplication. And so multiplication we're going to turn into addition when we separate it. And so we get natural log of 7 plus natural log of x cubed. And we can do the same thing over here. Now we do need to be careful because we do want to make sure that we keep that minus sign through both of these. So this is going to be minus natural log of k squared. I'm going to put my parentheses on the outside just so that we can kind of see what this looks like. Square root of m. So my multiplication turns into addition, but we do have that minus sign on the outside that we do need to make sure we keep it applied to both. All right, the next thing that I'm going to do is I am going to distribute my negative. We get minus natural log of k squared. We're going to distribute to the second one as well, minus natural log. And I'm going to go ahead and rewrite this as m to the 1/2. Okay, this is a square root. And so we can go ahead and write it as an exponent. The last thing that we need is we need to take all of these exponents and move them up to be coefficients. The first term, we don't need anything here, so this is natural log of 7. For the second one, we can move our 3 down to the front. And this becomes plus 3 natural log of x. The next one, we can move our 2 down to the front, and it becomes minus 2 natural log of k. And then the last one, we can move our 1/2 down, and we get minus 1/2 natural log of m. And we're done. This is expanded. Now, me personally, I don't like doing this step right here. I don't really like doing this step right here because I have a tendency to forget the distributing the negative when I do it this way. And so this is kind of the rule that I have. If it's on top, this is positive. If it's on bottom, it's a minus, okay? So minus or negative. And so, for instance, if we look at this one again real fast, I kind of take a little bit of a shortcut. And so basically everything here is being multiplied, divided, however you want to think about it. And so when I look at this, what I see is, okay, 7 is on top, that's going to stay positive. X cubed is on top, that is going to stay positive. I am dividing by k squared, which means that that's going to be a minus. And I am dividing by square root of m, which means that that is also going to be a minus. And so basically when I do this, everything on top is going to stay positive. Everything on bottom becomes negative. And then from there we go ahead and we finish it by moving our exponents to the front. So I'm going to start by rewriting my square root of m. I'm going to rewrite that as an exponent, so this is m to the 1/2. And when we move our exponents to the front, we get 3 natural log of x, minus, we have 2 natural log of k, and then we bring down our 1/2 and we get minus 1/2 natural log of m. And so we get the same thing as we did before. Just like we saw when we talked about rules of exponents, remember there are lots of different ways to do these problems, okay? And so we still have the same thing when we talk about logarithms. All right, let's come over to our last example, example F. Okay, so when I see this, the first thing I'm going to do is I am going to go ahead and take care of the division. We basically just have one thing on top, one thing on bottom. And so what this is going to turn into is log. I'm going to rewrite this as x plus 1 to the 1/2. And we have minus log of x minus 2 cubed. When we separate division, it turns into subtraction. All right, the last thing that we want to do is we want to move our exponents up to the front. And what we get is 1/2 log. And it's important that you keep the x plus 1 in parentheses. Minus 3 log of x minus 2. And same thing, we want to make sure we keep the parentheses so that we know that the x minus 2 is inside the logarithm, not just the x. All right, that takes care of our examples for expanding logarithms. The next thing that we're going to do is we're going to go ahead and combine. We want to write each expression as the logarithm of a single expression. And so basically on these is, again, we can separate and we can combine. We're going to go ahead and combine. All right, let's see what we can do here. So remember that when we combine, addition turns into multiplication. Subtraction turns into division. Remember, those are our basic operations that pair up together. All right, so the first one that we have is we have natural log of 2e plus natural log of 1 over e. And so when we combine this, let's see what happens. Addition turns into multiplication. And so what we get is natural log of 2e times 1 over e. We can simplify this. We can cancel our e's, and what we're left with is natural log of 2. And we're done. All right, let's go ahead and look at the next one. We have log base 2 of 27 plus log base 2 of x cubed. We can combine this again. Addition, when we combine, turns into multiplication. And so what we get is log base 2 of 27 x cubed. We can't do anything else with it, and so we are done. All right, in the next one, we have log of x cubed minus log of x squared. We have a subtraction, and so remember that when we combine this, subtraction turns into division. if we divide this, we do get log of x. Now, just to show you, there are a couple different ways that you can do this. This is the way that I would approach it when I do my combining. I always think, okay, move all the coefficients up to exponents, convert additions into multiplications, convert divisions into, combine subtractions into divisions, and that's what we do. Okay, but just to show you, again, that there's lots of different ways to do these problems. I'm going to go ahead and move my coefficients to the front. As I said, this is not the way that I think to do these problems, but it does work for this one. We get 3 log x minus 2 log x. And here we can combine these because they're both just log x's. And we combine them just like we do everything else. We subtract our coefficients. If we subtract our coefficients, we are left with 1. And then we have whatever it is we're combining, and here we're combining log x's. And so this simplifies down to 1 log x, or just log x. And notice that we get the same thing. Whether we think about, and we're doing the same thing. Notice that on the top one, when we combine it, we're using our rules for rules of exponents. When it comes to dividing things with the same base, we subtract. And if we move our exponents to the front, well, then we're still subtracting the exponents. And so that's what we have going on here. All right, let's look at a couple other ones. All right, the next one we have is log of 5 plus log of 15 minus log of 3. And so if you remember on the last slide, in one of the problems, we said, okay, anything on top is positive, anything on bottom is negative. And so we do the same thing when we combine. If it's positive, it goes to the top. If it's negative, it goes to the bottom. And so, for instance, when I look at this, what I see is I'm going to combine this into one logarithm. This is a positive log of 5, and so I'm going to put my 5 on top. We have a positive log of 15, so I'm going to put that on top, and we are going to multiply. And then I have minus log 3, which means that I want to move my 3 to the bottom. And now we can go ahead and simplify the inside here. And so what we have here is 5 times 15 is 75. Divided by 3. And this is log of 25. This is the way that I would do it, okay? But again, remember, you can do these lots of different ways. For instance, on this one, just to kind of show you that logarithms, you can do all sorts of crazy things with logarithms. When I look at log of 15, to me this looks like log of 5 times 3. And remember that multiplication, we can separate it. And so what we can do is we can rewrite this as log of 5 plus log of 3. We still have minus log of 3 here. We still have our log of 5 over here. Now what we can do is we can cancel those two. And we can combine our other ones. This is 2 log of 5. And we can move our 2 up to the top and get log of 5 squared, which is log of 25. And again, the only reason I'm showing you this is to show you that there are lots of different ways to do these problems. Okay, And there's not necessarily any one right way. Again, because it does say combine into a single logarithm, my first approach to this is to actually combine it, not to separate it and then try to combine it back. But again, we can do lots of different things with these. All right, let's come to the last one. Is this the last one? I think it is. Okay, we have 2 natural log of x minus 1/2 natural log of y minus 3 natural log of z. All right, before we can combine these, we have to get rid of the coefficients. In the last slide, remember that we took our exponents and we moved them down as coefficients. And so this one, we're going to do the exact opposite. We're going to move our coefficients up to be exponents. And so when we do this, we get natural log of x squared minus natural log of y to the 1/2 minus natural log of z cubed. And then our next step is to go ahead and combine this. So remember, positives go on top, negatives go on the bottom. And so when we combine this, x squared, this is positive in the front, so it goes on the top. We have a minus natural log of y to the 1/2, so the y to the 1/2 is going to go on the bottom. We have a minus natural log of z cubed, which means that our z cubed is also going to go on the bottom. And just to kind of practice, I want to rewrite my 1/2 as a root. And so what we have is the square root of y. It doesn't matter where you put these things. I'm going to put the z cubed in front. Just because I want to make sure it does not look like it's inside that square root. And we're done. This is combined, and that's all we can do with it. Oh, we do have one more. Okay, let's look at the last one. Last one we have 5 log base 3 of x plus log base 3 of 2x minus log base 3 of y. All right, so when we combine this, the first thing we want is I only have one coefficient, so I'm going to go ahead and move it up to the exponent. What we end up with is log base 3 of x to the 5th. We still have log base 3 of 2x minus log base 3 of y. All right, when we combine this, we have x to the 5th is positive, so it's going to go on the top. We have log base 3 of 2x is also positive. It goes on the top. And we have minus log base 3 of y, which means our y goes on the bottom. And we do want to simplify this. So the only thing that we need to do is we do want to go ahead and combine our x to the 5th times x, and that becomes an x to the 6th. We still have a 2, and we still have a y, and so our final answer will be log base 3 of 2x to the 6th over y. All right, now I think that's it. right. Last thing that I want to play around with is I do want to play around with change of base. And so if we go ahead and look at this, we have for our first example, log base 4 of 20. So our change of base, this is how I think about it. Okay, we are going to separate this. To me, the 20 looks like it's already going to the top. The 4 looks like it's already going to the bottom. And then we just need to take the log of both. This is a calculator problem. And so if we go over to our calculator and type this in, we should get 2.161. Again, when you're typing this, and that is a rounded answer, when you're typing this, make sure that you do close your parentheses around the numerator and the denominator. Again, you can use log. You can also do natural log. It does not matter as long as you are using the same one for the top and the bottom. All right, let's look at one more. All right, for this next one, we're going to do 2 of them. And so again, I want to start by doing my change of base. We get log of 125 over log of 2 plus log of 39 divided by log of 7. All right, I'm going to go ahead and type each one of these into my calculator and let's see what we come up with. I get this is 8.848. All right, that takes care of our properties of logarithms. In the next section, I'm going to go ahead and kind of explain change of base a little bit more in terms of why it works this way. Okay, but for now, this is the end of the second to last section. We have one more section to look at, and we'll go ahead and look at that soon. All right, that'll be it for this one. Thank you for watching. Have a good day.